Also, by the way, just a thought for you. Sometime after spring break, whenever this unit is done and we're launching it to our next unit. Next unit is planned to be the reversal unit. What I mean by that is lecture will happen at home for homework. I'm not going to lecture in class. Lecture will happen at home for homework via video. Okay? You watch video of me lecturing. Okay? Oh, I'll be here. And then, listen. Then, yeah, this stems from that. Then you're going to come into class where you would do what you used to do for homework, all the problems, in here. This has two distinct advantages. Advantage number one, you get to go through the lecture at your own pace. You get to go through the lecture at your own pace. In other words, you currently have a thought of, Mr. Birch, I feel like you go too fast, I'm always slowing you down, oh my gosh, I wish that there was a big TiVo remote, to where I could actually hit pause on you, and, you're going fast, I want to hit pause, I want to write down what you have. There's an advantage to this. Video, you have a pause button. You can pause me as often as you want to write things down. You think that a PowerPoint slide is going through too quickly and you need to read it and go through it again, think about it, pause button. That's the advantage of this. Or, if you're kind of the opposite, Mr. Birch, you are slow. You are boring me. Yes. Please go quickly. That's fine. Let the video play. Just let it run. Since it's just me talking, then I'm not going to really slow down during the video, right? It's just going to go straight through, condensing lecture down, with the knowledge that whenever you're writing notes, you're going to pause. What's going to be required for you is to actually have notes for me, okay? I'm going to come around and check, do you have notes from the previous lecture that you just watched last time? It varies. Generally, my lectures last, 30 minutes in class, right? And so you're looking at it being reduced down, since I'm not, you're looking at it being reduced down to 20, 15 minutes, more than likely, video lecture, and then you're going to take notes over that. Wait, let me continue to explain. So, advantage number one, you get to watch video at your own pace. Advantage number two, and this is where the biggest advantage, in my opinion, comes in. Instead of you going home, you trying the homework, you not knowing how to do problems, you coming back to class and looking at me and say, I didn't know what to do, Mr. Birch. You're doing those problems in class. So whenever you run into a brick wall, you can ask, okay? Because the only other way that this would happen is if, for some odd, weird reason, I came to your house and that's just creepy. So that's not happening. So we're gonna try to reverse it just to see how it goes for a unit. What will be your homework is watching the lecture, taking notes, and we'll take the first, I don't know, say 10 minutes of class, and I'll take questions. Okay? So all those questions that you wanted to ask me, but you couldn't exactly ask the computer screen. You ask me whenever you come in. So I take questions for about the first 10 minutes, and then I give out what would have been your homework, but now is the class work, and I turn you loose. As long as you're working productively, we're good, right? And so you do that, we reverse class, and it should better your education. We'll see. What that means is you need to, over the next week or two, figure out a way to watch video. Pretty much everybody in the technology survey said, yes, I have some way to watch video, whether it's a internet-connected computer, non-internet connected computer, or some other method. There will be, I'm going to put all these videos up on YouTube. Okay, I'm going to go through the same avenue with YouTube. So if you have internet at home, you're good. Log on to YouTube. You go to my website, click the link. There are the videos. Good. Okay. If you do not have internet at home, that's fine. I'm also going to have all these videos still stored on my computer. Right. That means I can put them on a flash drive for you. I can burn a CD for you. I can, however you want me to give you those videos, I can get them to you. Okay. So if you're thinking you don't have internet, have a computer. I can give you the videos, or you're starting to think, here's another option that you can figure out. You're saying, I have some other personal device, an iPad, an iPod Touch, whatever. I don't have internet at home, so I can stream YouTube. I need to actually download the videos onto it. We can make that happen also. So if you don't have internet at home, that's cool, that's not a problem. You can come and see me, right? Tell me what you have, and then we'll figure out how we're going to get videos to you. And this won't be immediately after spring break, but will be very soon after spring break that we'll be doing this. Okay.
Are comments on your videos allowed?
No.
Mr. Bird.
Yes.
If you like put burn on the DVD so I can like play it on my TV.
Yes. Yeah. Here's.
Everybody just flag the video, so we can't do that. Flagging is inappropriate. Is this what you look at?
Working this problem. Collapse all the way down, expand all the way back out. Collapse all the way down, expand all the way back out. So, especially for those of you who aren't here, make sure you pay close attention. First step that I need to do is get down to equivalent resistance. What are the, and really you could do three of them at the same time, what is the simplest set of resistors on this picture? The parallel, which ones? Yeah, the 7532 over here on the left, 7532 on the right, the 32 and 45. I have three sets of parallel resistors, right? They're already on the far outside. They're all equally easy, right, to see and to do. So I'm just going to do all three at the exact same time. Why not? Okay. So that's going to give me a picture that looks, let me get my battery right, it's up here, 40 volts like this. That's going to give me a picture that looks like this, and I'm going to actually have to calculate. I'm going to actually have to calculate what those resistors are. So over here on the right, this is 1 over 32 plus 1 over 75 equals 1 over R total resistance there, right? So you add those two inverses. You add those two inverses and take the inverse of that. What does this resistor come out to be, please? 22 point, I'm sorry, 22.429, so.
How would you do it, isn't it?
Kiloohms. Now, do I need to convert to base units here? Not yet. You can, and if you did, that's fine. What does kilo mean? Times 10 to the third. Here's why I'm saying you don't have to convert. When in doubt, convert back to base units. Here's how I know I don't have to convert. I'm plugging kiloohms in for both resistors. There is no other constant in this equation, nor is there any other variable in there, right? The only unit that's going in is kiloohms. So what am I going to get out? Kiloohms, right? Now, if there was some other unit in there, right, if, for example, F equals ma, right, force equals mass times acceleration, right? There, I've got different objects with different units being multiplied, mass, kilograms, acceleration, meters per second squared, and if you don't have the right base units, whenever you multiply those two, you wouldn't get the Newton out. Okay? If you had, instead of kilograms, grams, you're not getting the Newton out. Okay? You're getting something different. Anyway, that resistance is going to be the same resistance as over here, correct? Because they were the same. They were the same set being added. Now this bottom one, it's different. This is 1 over 32 plus, and this is once again in kiloohms, plus 1 over 45 equals 1 over the RT. So what's that bottom resistance come out to be? 18.7. Looking at this, all those resistors make sense. Parallel means the total resistance should go down, be less than all the others, right? 22.4, 18.7, for each of their sets, it is less than the two that were added together, okay? Less than the two that were added together, so that should make logical sense. Next, go all the way down to the final equivalent circuit. Single resistor. What's that single resistor going to have? What's its resistance? R equals. $63.5 kiloohms. In series, all you have to do is add them up. 3 were in perfect series, stuff them all together. Now, the reason why I work all the way down here, the entire purpose of working all the way down was to get to a simple circuit where I could actually use Ohm's law and start calculating things. Whenever it was a more complex circuit, I couldn't use Ohm's law and start calculating things. Right? I didn't know enough. But you work all the way down to the simple one and then step by step by step expand back upwards, and you can use Ohm's law in every step to figure out what you need. What's the one thing that I'm missing in this simple circuit? Current, I, right? I equals question mark. So this is, using Ohm's law, 40, with a period after it, note the sig fig, but we can do the sig figs at the very end, was I times 63.5. Now, 40, 63.5. 63.5 what? Ah, good. Times 10 to the third. What does I come out to be, please? 6.29 times 10 to the negative fourth. You're going to start seeing me use this. What does MA there stand for? Milliamps. 6.24, 2429. 29. Times 10 to the negative fourth is 0.629 milliamps. Whenever you have voltages in whole numbers, okay, voltages in whole numbers, and resistance in kiloohms, the current, if you don't convert, the current will come out in milliamps. So just for the sake of not having to worry about times tens of all this stuff, I'm going to just start using milliamps from here on out in this problem. Okay? If you have times 10 to the negative fourth, all that in base units, that's perfectly fine. So, all right, so I have current. Now, working back up a step. Here, those are in series or parallel. Series, what stays the same? Current. So each last one of these gets I equals 0.629 milliamps. What am I looking for all three? Voltage. Use Ohm's law to get it. We'll do the one on the left as an example and let you tell me what the voltages are for all the others. V equals I 0.629 milliamps times 22.4 kiloohms. Kiloohms times milliamps is going to get me back to standard volts. Okay? And that's just a trick I know in my head that I'm telling you right now. Kiloohms, milliamps, regular volts. How many volts does this left one have? What's the voltage? 14.1 approximately volts, okay, using Ohm's law. Now, we know what the voltage is in here. Everything's the same. This must be 14.1 volts also. And this bottom guy, use Ohm's law, and what do you get? 11.7? 1.7 or 1.6? Which is 1.7. Okay. Know everything on this one? Go back up. Thankfully, we're already at our final step back up. Now, I expanded, just kind of thinking with a comparison here between them, I expanded each of these resistors back out into what? Into parallel, right? I split each of those three resistors in two, right? And I split them in two into parallel, right? I put them back into parallel. What stays the same in parallel? Voltage, right? So that means the voltage of each of these guys, right, it's the same voltage of the two on the left and the right was 14.1. And the voltage of the two bottom ones was 11.8. All right, and what's missing from all these resistors? Currents. And now you're going to go back through Ohm's law for each resistor, figure out what current is. I want to just do one as an example here. Let's do the far left with the 75 kilo ohm guy. All right, this is Ohm's law, right? V equals IR, 14.1 equals I times 75 kilo ohms, right? So I comes out to be how many milliamps? 0.1196? 0.196?
I didn't know.
0.188, 0.1.
188.
Approximately 0.19 milliamps, depending on how many figures you've got calculated all through that. Or if you're getting in standard base units and amps, you're going to have 1.9 times 10 to the negative 4 amps. Okay, 1.9 times the approximately 1.88, whatever, times 10 to the negative 4 amps. Whenever you've gotten all the way through this, you've got to come back and deal with sig figs. How many sig figs were you given in this problem? 2. All the resistors have 2 sig figs, and the battery has 2 sig figs in it, right? So you would have to then round all of your answers off to 2 significant figures. Questions?